Hey everybody, this is Mr. Mazzoro, and today we're going to finish up our generalized discussion about adaptations that fish have for living in the pelagic oceans by talking about mating. Mating in the surface and also mating in the deep, which isn't just the subject of today's lesson, it's also the name of Adele's new album. Today, we're going to, just like we did before, divide the pelagic ocean into two zones. We're going to talk about the epipelagic first, and then the deep. We'll talk about schooling and what that has to do with mating in the surface. We'll talk about what organisms do if they can't find a mate in the surface. And we'll talk about once they do find a mate, if they do successfully bear young, how that actually happens in the surface. And then we're going to go into the deep. And if you haven't noticed, there's a really limited amount of information that we have to share about deep sea organisms, and we know even less about their mating habits. I mean, we can kind of determine a lot more about defense and offense and finding food and avoiding predators and general anatomy for staying above the ocean floor. Mating, we kind of have to look at an organism do it. So we know even less about how deep sea fish find mates than we do about really anything else. So it's going to be kind of a short lecture there. But here we go. First, let's start with the surface. A group of fish is called a school. And a lot of people would say that fish school because they're either trying to avoid being eaten or they school because they're trying to get food. And that would mean that fish are schooling all the time because they're constantly being hunted, which is a horrifying idea if you're a fish, or they're constantly finding food and there's just not that much food in the ocean. The main reason fish school is actually mating. Mating is absolutely the number one reason why fish school. The reason why fish get together in large groups is the same reason why a lot of people get together in large groups, because it increases their chances of a successful mating encounter. They also school for protection. They also school to find food. They also school in order to help break the water in front of them so that they can necessarily swim easier or more efficiently to a location like these fish are. See how one fish is basically swimming directly behind another, so this fish doesn't have to work as hard as this fish does to break through the water. That's swimming efficiency, drafting, if you know anything about NASCAR. All three of these reasons are reasons why fish school, but the number one reason why fish school, the most important reason why fish school, is to mate. If fish can't find a mate inside that school, or they school at a different point in their life cycle and they're not actually of mating age, they have actually another way of becoming pregnant or mating or reproducing. And that's the fact that a lot of fish in the epipelagic ocean are hermaphrodites. They're not he's, they're not she's, they're he-she's. They're Lady Gaga fish. They're basically fish that have both male and female sexual organs. There's two flavors of hermaphrodites in the epipelagic on the surface. You could be a simultaneous hermaphrodite, which sea bass are, as well as some hamlet fish, those organisms. These fish have, as the name would suggest, both male and female sexual organs simultaneously. That means that they can release sperm into the water and then have that sperm fertilize their own eggs, which are in the water. This is asexual reproduction. It doesn't provide for any genetic diversity, so it's not favorable, but if you're a sea bass and a hamlet fish and you just can't manage to sexually reproduce within your life cycle, this is a good kind of like backup plan. There's also fish that are sequential hermaphrodites, fish that have the ability to start their life as one sex and then, due to certain environmental pressures, switch to the opposite sex. Clownfish, like Nemo, are a classic example of organisms that are sequential hermaphrodites. Clownfish school in an anemone, and the largest clownfish in that school is a female. All the other clownfish in that school are male. When that large alpha female dies, the next largest male becomes the alpha female, and all of the other clownfish kind of move up in the order. So when Nemo lost his mother in the beginning of the movie, he would have proceeded to start to become a person or a fish of the opposite sex. Hermaphrodism is a big way that organisms can guarantee that they actually mate in the epipelagic zone if they can't find a fish, if they can't find another fish to mate with. It's not ideal because, again, it's asexual, but at least it'll carry on your genes. Once epipelagic fish mate, they or release eggs and sperm, they have a choice of doing that either externally or internally like we do it. Very, very few organisms in the ocean internally fertilize. And the reason why very few organisms internally fertilize is because internal fertilization requires an external phallus. And external phalli create a lot of drag in the water. It's hard to swim around with an external phallus your entire life, especially when you're only going to use it for a couple mating encounters, and the rest of the time it's just causing you to have to swim a lot harder. As a result, only sharks and marine mammals really fertilize internally. And of sharks, most of them don't fertilize internally, only a few of them do. By far and away, external fertilization is going to be the preferred mating method in the ocean, in the epipelagic. And the word for external fertilization is going to be broadcast spawning. Most organisms release eggs into the water and sperm into the water, and the two meet and you get a baby. There's no insertion, there's no internal fertilization. It's just eggs and sperm go into the water and the two meet. Once those eggs are and sperm are in the water, once sexual or asexual reproduction happens, how are the fish going to actually bear young? Well, there's three different choices. The first is oviparous reproduction. Oviparous reproduction means laying an egg. Ovi means egg. Parous means birth, so egg birth. What's an egg? An egg is something that protects its embryo with a shell and feeds its embryo with a yolk. Eggs have shells and yolks, so if you lay an egg with a shell that's feeding its embryo with a yolk externally, you're an oviparous reproducer. You reproduce by laying eggs. The other option is viviparous reproduction. Vivi means live and parous means birth, so live birth organisms. These organisms don't protect their babies with a shell. They protect their unborn with a womb. And they don't nourish their unborn with a yolk. They nourish their unborn with an umbilical cord. Oviparous egg birth, viviparous live birth, marine mammals, some sharks. Now, there is a third option in the ocean, and only some sharks do it. It's a mesh of the two. It's ovoviviparous reproduction. Ovo means egg, vivi means live, so egg, live birth. How can that be? Well, sand tiger sharks like this organism and some other sharks do this. That's basically where they are internally fertilized and the eggs are never laid. They just remain inside the mother. When the babies run out of yolk, they hatch, but they're still inside the mother. And they're not fully developed yet, but they are out of food. So at this point, the unborn hatchlings are actually going to begin to consume each other. The larger of the babies is going to be usually the last to survive, and then that baby will be born live into the water. This is kind of brutal, eating your brothers and sisters in the womb, but it's actually kind of a clever adaptation to ensure survival of the fittest, that the largest and toughest of your siblings is the one that's going to survive. Granted, it means cannibalizing your sisters in the womb, but, there you go. So oviparous, eggs, that means yolk and shell. Viviparous, live, that means womb and umbilical cord. Ovivivi, yolk and shell, but it's internal. Babies hatch, eat each other, and then born live. Only some sharks do that last one. Again, not a lot's known about how organisms mate in the deep, because we really can't tell how organisms are mating in the deep just by dragging up their corpses. We have to really see them do it, and that's exceedingly rare. We know by dragging up some organisms' corpses that most organisms in the deep ocean are hermaphrodites. It makes sense, right? There's not a lot of fish in the ocean. There's even less fish down in the bottom of the ocean. So being a hermaphrodite is going to help you guarantee that if you don't come across any fish in the big, deep, dark ocean, that you're going to be able to fertilize yourself and at least carry on your genes that way. We also know that organisms use bioluminescence in order to help themselves mate, and we know that because bioluminescence often differs according to the sex of an organism. It'll be different colors or it'll be different patterns depending on whether it's a male or female of that organism. Last but not least, organisms can't see in the dark, but you can smell in the dark. So the way organisms will often attract each other in the deep ocean is by releasing pheromone or sex hormones into the ocean. And then the males or females will spend their lives actually smelling for the pheromones released by the organisms that release them. And that's how they find each other. Basically releasing perfume into the water that attracts the opposite sex. There is one major adaptation that we know organisms use for mating in the deep, and it's called male parasitism. Most famously, it's been, documented in anglerfish, this guy. This is a female anglerfish, and this is a male anglerfish. Close up, it would look like this. The male anglerfish really isn't a fish. It's really just a swimming pair of testicles with a nose. It's not going to spend its life swimming looking for food. It's not going to spend its life swimming, staying above the ocean floor. It's really just going to spend its short life smelling the water for pheromones released by the female. Once it locates that female, it's going to gently gnaw on her stomach until it actually gains access to her ovaries. And then the male is basically going to rot away. And its corpse is going to remain permanently fused to that female. This way, every single time the female goes into heat and is ready to have a fertilized egg, she has a ready and waiting pair of testicles hanging off her stomach to fertilize that egg. It's an elegant solution to guarantee sexual reproduction every single time that you become in cycle in a dark, deep ocean where there aren't going to be a lot of fish, let alone a lot of fish to mate with. More to the point, some toothed sea devils, this fish, and other fish have been dragged up not with one male parasite, but 2, 3, 4, 5 male parasites, multiple male parasites. So now not only do you have sexual reproduction, but now you have genetic diversity in spades because you have not only sperm from one male, but sperm from multiple males. Male parasitism, along with bioluminescence, pheromones, and hermaphrodism, are all ways organisms actually find mates in the dark. So, to review, right? We've talked about schooling, yes, for defense, yes, for offense, for finding food, yes, for swimming efficiency, but mostly to mate. Fish mostly school in the epipelagic because they're trying to mate. And we also talked about if they can find a mate, most epipelagic fish are hermaphrodites, either simultaneous hermaphrodites, where they have both male and female organs simultaneously, or sequential hermaphrodites, where they can become a member of the opposite sex given certain environmental pressures, like the death of a female, or in an all-male or all-female environment. And last, we talked about once they eventually do fertilize, that very few epipelagic fish internally fertilize, most broadcast spawn, and then they're either going to lay the eggs externally, oviparous reproduction, or if you're a marine mammal, you're going to have bear live young, viviparous reproduction, or if you're some sharks, you're going to have eggs that are internal, that are born live, that's oviviviparous reproduction. In terms of the dark, mating, kind of not a lot's known, but we do know that there's lots of hermaphrodites. We do know that organisms release a lot of pheromones into the ocean, which help them lure organisms to themselves in the dark through smell, or they have bioluminescence that helps them do that. And last, we know that male parasitism is rampant, that many organisms in the deep ocean are females, and then the males are basically small, underdeveloped fish that will permanently fuse to the female once they locate them via pheromones and allow the female to have a constant and permanent supply of semen to fertilize her eggs every single time she's in heat. So that's it for the general adaptations of finding food, staying above the ocean floor, and last, mating in the pelagic ocean, the epi, meso, bathy, abysso, and hadopelagic zones. In the next series of lessons, we're actually going to get down to the anatomy and physiology of not only cartilaginous fish, sharks, skates, and rays, but also bony fish. Bony fish that you typically think of as swim around in the ocean. Both the external differences of those organisms as well as the internal differences of the organisms. But that's next time. Thanks, guys.